A foundation model is a large AI model trained on broad data at massive scale that can be adapted for a wide range of downstream tasks. The term, coined by Stanford in 2021, describes models like GPT-4, Gemini, Claude, and Llama that serve as the starting point for countless applications. In the next few minutes, we will explore what makes foundation models distinctive, what capabilities emerge at scale, and how organizations build on top of them. Let us get started. Let us understand what makes foundation models so transformative compared to the task-specific AI models that came before them. Foundation models represent a paradigm shift from narrow task-specific models to general-purpose bases that can be adapted across an enormous range of applications. Let us define the essential vocabulary for understanding how foundation models are built and adapted. Pre-training is the computationally intensive foundation of the foundation model paradigm. During pre-training, the model processes massive quantities of text using a self-supervised objective, typically predicting the next token given all preceding tokens. This simple objective, applied at sufficient scale, forces the model to develop internal representations of grammar, semantics, factual knowledge, reasoning patterns, and the structure of countless domains. Pre-training produces a model with broad capabilities, but no particular specialization. It is the expensive investment that makes all subsequent adaptation possible and economically worthwhile. Downstream tasks are the specific applications that justify the investment in foundation model pre-training. A single pre-trained foundation model can be adapted for text summarization, sentiment analysis, question answering, translation, code generation, document classification, and hundreds of other tasks. Each of these is a downstream task relative to the general pre-training objective. The remarkable breadth of downstream tasks that foundation models can perform, with minimal additional training, is what makes the paradigm so economically and technically powerful compared to the narrow task-specific models of the previous generation. Adaptation is the process of specializing a foundation model for a particular purpose. At one extreme, adaptation can be as simple as crafting a well-designed prompt. No weight changes, no additional training data, just a carefully written instruction that directs the model's existing capabilities. At the other extreme, adaptation involves full fine-tuning where all model parameters are updated on a curated task-specific dataset. Between these extremes lie parameter-efficient fine-tuning methods like Llama that update only a small fraction of parameters. The right adaptation approach depends on the performance requirements, available data, computational budget, and privacy constraints of the application. Emergent capabilities are one of the most surprising and consequential phenomena in foundation model research. As model scale increases, more parameters, more training data, more compute, capabilities that were absent or negligible at smaller scales suddenly appear with much greater proficiency. This nonlinear relationship between scale and capability means that larger foundation models are not just incrementally better, they are qualitatively different, capable of tasks that smaller models simply cannot perform. The existence of emergent capabilities is one of the primary justifications for the continued investment in ever larger foundation models, even as each scale increment becomes more expensive. Now let us see how organizations across industries access and build on foundation model capabilities. Organizations access foundation model capabilities through several distinct patterns, each with different trade-offs of cost, control, privacy, and performance. Let us close with the 4 most important lessons from this overview of foundation models. To explore more key concepts in generative AI, check the link in the description. If you found this helpful, please like and subscribe. Thank you for watching. If you found this helpful, please like and subscribe. See you in the next video.